Okay, so with this idea of vector direction and magnitude, let us proceed to the next topic where we are going to discuss what are called as unit vectors. Unit vectors have a very simple definition. Any vector whose magnitude is said to be 1 is termed as a unit vector, right? So let's take some examples. The simplest example can be, if we take a vector 1 0, the magnitude of this vector is 1, or if we take 0 1, the magnitude of this vector is 1, right? One common mistake that we tend to do is, we sometimes may pick up this vector 1 1 and may sometimes mistake it to have the unit vector, but that's not unit vector, right? If you find let's find the magnitude of this vector. Magnitude of this vector will be 1 square plus 1 square, which is actually root 2, right? Okay. But given any vector, right? So if we are given any vector, let's say that we are given this vector, is it possible to find the unit vector in this direction? So here also we can ask, since this is not a unit vector, can we find the unit vector in the same direction? Now what is the knowledge that's going to help us? Just now we have understood the concepts of magnitude and direction, right? We clearly understand when we say we want the unit vector in the same direction, which means that it must have the same slope, right? So you see here that when I run one step, I would like to rise one step, right? So that's the kind of the slope we are looking at. At the same time, we want its magnitude to be 1, right? So with this understanding, let's ask how do we do this? So since we know that the magnitude of this vector is root 2, let us simply divide this vector by root 2. That's it. But then we don't know what is called division. What we essentially saying is that do a scalar multiplication by the inverse of the magnitude, right? So 1 by root 2 scalar multiply this with the vector, and we know now what will be the output. So let me call it u. So we multiply each of those components, and therefore this will be 1 by root 2 and 1 by root 2. Now you can calculate the magnitude of this vector, that will be actually 1. So here you can calculate this. But what is interesting is you can see the slope of this vector, right? So for moving this much or running this much, I rise this much, which means that the slope is exactly same as this, which means we found a unit vector in the direction of 1 1. Fantastic. Similarly, if you are given any general vector like this, what do we write for that? So unit vector u in the direction of v is going to be 1 by root of x square plus y square, and we do a scalar multiply of the original v vector. This is my unit vector in the direction of v. Another way to handle unit vectors or find unit vectors is to look at what is called as the unit circle, right? So with a radius of 1 at the origin, if we have a circle, then any vector which is touching that unit circle has got to be a unit vector, simply because the radius of the circle is 1, right? So when we look at the unit circle, we can also look at this kind of a format for unit vectors. So pick up any theta and fill this up. Any cos theta sin theta pair will always form a unit vector, right? Reason is because we find that root of cos square theta plus sin square theta, for any theta this is going to be 1, right? And therefore this will always form a unit vector. So now that we have an idea of vector, magnitude, direction and unit vectors, let's move to something more interesting. Okay, so here we see that we have two vectors a and b, and let's say that we are now interested in asking, here it is, let me just write this down. We are interested in length of the shadow of a vector on b vector, right? So it's a very important statement we're looking at. We are suddenly interested in finding See, we know how to find the magnitude of A vector or B vector. We know how to find their direction. Okay. What we're interested now is, we are interested in finding the length of not A but its shadow that is cast on B. Okay. In this case, we have picked up the B, which is very simple B because it's in the direction of in the direction of x-axis. Is it possible to find the length of this shadow? Okay. So what are we going to do? We are going to assume rays of light in this direction, let's say, and the shadow is cast. I mean, we have a fair idea of this concept. And what is going to happen is, as the shadow falls, it's a perpendicular projection here. And it's pretty easy to identify this point, is it not? Right? You know, we are saying this is 3, 4. 3, 4 means that I have moved 3 steps here, and 4 I have risen up in the y direction. But since the shadow is going to fall flat on the x-axis, this point is simple. It's going to be a 3, 0. Right? Okay. And we are looking at what's the length of that, right? So it's pretty easy to understand it. The length of this is going to be simply 3, nothing more to it. But we want to talk about this using the direction concept as well, which means that, you know, if we mark this angle to be theta, you would like to know what is this part, you know, what is the shadow part. So let me call this as, say, S is the shadow, right? So B is the vector in yellow, which is still 4, 0. S is that smaller part, the 3, 0 vector. But we want to find S in generic terms, right? We are not worried only about the example 3, 4. We want to find it for any A that is having a direction theta. Okay. So it's pretty simple, you know, using trigonometry. Let's ask ourselves if this is theta. Okay, here is a right angle here. Therefore, what could be cos theta? Right? Cos theta will be adjacent by hypotenuse. So I can write here cos theta is actually S by A. Right? So when I write like this, be careful. It should be the magnitude of the S vector by the magnitude of A vector. Right? Or if you want the length of the shadow, it is simple. You give me the vector, I can always find the magnitude. Given the vector, I can find the magnitude, and let's say the direction is given for now. All that I need is simply use cos theta, and I have got the length of the shadow. Now, when we look at this length of the shadow, it actually hardly matters, you know, it really doesn't depend on the B vector as such, right? We could say that it depends on theta, and theta is actually the measure of the angle from the x-axis to A, which in essence is going to be the same from B vector to A. Okay, let's try and generalize this, right? So instead of calling, you know, as B vector or X or whatever, we will say, you give me some B vector. From where I measure the angle theta. Instead of the B vector, why don't we look at the unit vector in the direction of B? Right, so this is what I'm going to write. If theta is the angle between A and B vector, what will be the angle? What will be the angle between A vector and the unit vector? The unit vector in the direction of B vector, right? See this angle between A and B vector is theta. Okay, and we are finding the unit vector in the direction of B. Now you understand this statement because we just now completed what is unit vector. Therefore, the angle between A and the unit vector in the direction of B has got to be the same. So this will also be theta. Okay, so this is how we are trying to generalize it, right? So given A and B vectors, we will be able to give the length of the shadow of A on the unit vector in the direction of B, and that will be the magnitude of A cos theta. So let's call this unit vector in the direction of B to be, say, some u vector. Let's say we call this as the u vector. Okay. Now people are quite interested in the length of the shadow, basically because we are going to use this concept called as projection many times, right? And that is why there is a keen interest in this, in the length of the shadow, because it's projection, right? And that is why this has got a definition in vector algebra, and this is defined, this part, magnitude of A times cos theta, has got a definition, right? This has been defined as A dot U, right? You know what is A vector? A vector is given to us. U is the unit vector in the direction of B vector. This is a definition, right? So this is called a dot product. A dot product is a scalar definition, right? This is it involves two vectors, but its output is a scalar. It's a number, a real number. So we pick up these two vectors and then bring up a scalar. What does that represent? It represents the length of the shadow of one vector on the other vector. Okay. Now, if you want to further generalize it, right? We know that U is the unit vector in the direction of B, and just up here we saw what are unit vectors. So instead of writing it like this, now I can write it as A dot B divided by modulus of the magnitude of B, right? So we can also write it like this and say that this must be equal to A cos theta. But since the dot product is only between vectors, we can bring the scalar out and take it to the other side, and therefore they come up with this definition which looks quite decent and symmetric, and this is called as the dot product of two vectors. So given any two vectors, a dot product of them is defined as the product of their magnitudes times the cosine of the angle between them, right? So we may think that this kind of a definition works only when B is in the direction of X, or we have taken it aligned with the axis. Not really so. So we can pick up another example right here, and we will see how this works. So let me pick up another vector. I've drawn another vector in orange. So let's say that this vector is 4, 2, and let's ask this question: what if this is the, let me give it some name. Let's say this is the C vector, and we're asking how do I look at A dot C, right? How do I look at it? Because the definition is going to be the same, so I'm going to write here the product of their magnitudes times cos theta, but this theta this time is not this theta, it is this, which means that if I call this as theta 1, let me better put it here as cos theta 1, but theta 1 is the angle between A and C. How does that work? Okay, what we do is, remember when B was in the direction of X, it was very easy to drop the perpendicular. Okay, now if we want the shadow of A on C, what we need to do is we have to imagine rays of light perpendicular on C, right? Like this, right? So let me draw the perpendicular carefully. So in this direction. So we have rays of light hitting perpendicular on A at C, and we find that the shadow of A will be cast on this C, right? So let me just try and project this. Okay, so it may fall somewhere. Now we can even extend this vector how much ever we want. Sometimes if the unit vector in this direction is smaller, of course we know that it will only touch the unit circle here, so we can extend that and then meet it, and that will be the length of the shadow, right? And you see that there is a right angle triangle again forming here, right? So look at this triangle here, and we know that this is A. This is the shadow part. This is the shadow length is going to be S, and this is a theta 1. Apply the same trigonometric rule and we will get the same thing. So our formula still remains the same, right? Now interesting question is going to be, what happens to the length of the shadow as the base moves closer to A, right? Initially we had this B vector on which I had the shadow. It looked a little small to me, Now when I move a little closer, when I move my base a little closer and then cast the light now, it appears a little longer to me, right? Okay, let's go as close as possible. What will happen if I ask for the length of the shadow of A on A itself? Right, of course we will still say that I am going to give the shadow length on the unit vector. Okay, but the direction is going to be the same, but the point here is that what will be the length of the shadow? The length of the shadow has got to be the same as the magnitude of A. Let's ask, is that correct? Let's try. We are saying this is my length of the shadow, and we know you give me any vector, this is what it's going to be, where theta is the angle between A and the B vector or the unit vector in the direction of B. Now what's our B in this case? A itself. Therefore, what is theta? There is no angle, which means it's 0. And what is cos 0? It's 1, which means that this is going to be A. The length of the shadow matches the magnitude of the original vector, right? So this is the concept behind what is called as the dot product, and in the next session we will be dwelling a little more deeply about dot products. Right? So let us end this session with a prayer. Om Shanti Shanti Shanti.